Today, inshallah, we shall provide a Cartesian plane proof of the Mid Segment Theorem. Now, in general, we like to provide geometric proofs for geometric theorems. However, at the present time, we don't have the requisite knowledge to prove the Mid Segment Theorem using geometry. So, we'll have to settle for now for using a Cartesian plane proof. In the future, inshallah, we shall revisit this theorem and try to prove it using the geometry that we have learned. If you recall, the mid-segment theorem says that if you connect the midpoints of two sides of a triangle, the resultant segment, the mid-segment, is parallel to the third side, and it is 1/2 the length of the third side. So that is what the mid-segment theorem says, and we shall try to prove this using the Cartesian plane model. Now, we have a triangle here, triangle ABC, a hypothetical triangle, and conveniently we have placed it in the Cartesian plane on the x-axis. Now, we do proofs like this from time to time using algebra, and you can place the triangle any which way you want, but it helps in this case to put it like this, okay? And each of these vertices of the triangle will have a ordered pair. Of course, A here is at the origin, so its ordered pair would be 0, 0. Now, C will have an ordered pair. It will have some x value. You can call it P, and the y value would be 0. And then in B here, we'll have some ordered pair. We don't know what it is. You can call it R, and you can call it Q, and you can call it R like that, okay? But instead of calling this P and 0, it's helpful to call this 2P and 0, and you'll see instead of calling this Q, it's better to call it 2Q and 2R. So you can label these points any way you like. However, as I suggested, with a little foresight, and you will see why this is this works better. So I label this ordered pair that belongs to C as 2P and 0, the y value is 0. And I label this ordered pair that belongs to B over here as 2Q and 2R. It could have been just QR and P0, as I said. Now, that would have worked just fine, but this will make mathematics a little easy for us, okay? Now, we have two things to prove. One, we have to prove that this segment, which is DE, that's the mid segment, okay, I'm going to say, DE is the mid segment, is going to be half the length of AC, okay? So we are given that DE is the mid segment of this triangle. And then we are to prove, therefore, that DE is 1/2 the length of AC, okay? So DE equals 1/2 the length of AC like this. That's one job. And then we also have to prove that DE is going to be parallel to AC. So once we've done that, we have completed our proof, so to speak, right? Okay, so let's try to figure this out. So let's try to prove that DE is half of AC over here. Well, to figure that out, we have to know the ordered pair that corresponds to D and E, right? So, these are midpoints, so this is going to be congruent to this, right? AD is going to be congruent to DB, and BE is going to be congruent to EC like this. From there, we can generate the ordered pair that corresponds to D, right? So we just call that D. Now, D is going to be the midpoint of A and B, so it's going to be 2Q plus 0, that's the x divided by 2, right? And that's Q. So the x value for D is going to be average of this and the 0. Well, that's easy because that's just going to be Q. And then the y value for D, point D, is going to be average of the R and 2R and 0. Well, that's going to be good. That's going to be just R. So that works out. See how now you can appreciate why that funky notation is helpful. Now, E is going to be the same thing. E is going to be average of 2Q plus 2P, right? Divided by 2, okay? And then 2R plus 0 divided by 2. So this is point E, right? So the average of the x's and the average of the y's. All right, so if you simplify this, you can factor out a 2 from here again, right? So it becomes 2 times p plus q over 2, and here this is just r, right? Like that. And so this becomes just p plus q and r. All right, so that's fair enough. So this is going to be p plus q and r. Now, the way I got e and d was just I calculated the midpoints. Midpoints is the average of the x's and the average of the y's. Like this. The midpoint is the average of the x's and the average of the y's. So I got that. Now that we know all these points, we can calculate the lengths of these segments. So the length of AC is simply going to be from here to here, right? It's going to be 2p minus 0, so it's going to be just 2p. And then the length of DE, well, it's also a horizontal line. It's going to be PQ. Okay, that's this, right? And minus this right here, okay? The x value. So it's just going to be from here to here. The 2x values over there. So it's going to be PQ minus Q. And that is simply P, right? Okay, because these two will cancel out. So, and as you can see, then AC is 2P and DE is P. And we have proven that DE is half the length of AC. Okay, that's pretty good. Now, in calculating the slope of these, and you can see the slope of AC, it's a horizontal line. The slope of AC, you can call it AC, it's a horizontal line, changing y or changing x as 0 over 2p, and that is 0. And the slope of DE is also changing y, okay, r minus r, over changing x, which is p plus q minus q, right? So changing y is going to be 0. So I'm calculating the slope of DE using these 2 points, that ordered pair. Okay, changing y over changing x, r minus r over this minus q, and that's 0 over p, which is 0. So as you can see, they have the same slope. Since AC, okay, since the slope of AC equals is equal to the slope of DE, the AC is parallel to DE. Okay, so this is a algebraic Cartesian proof of the mid-segment theorem. The trick here was to place a triangle like this in the Cartesian plane, assign some ordered pair to each of these points, and in this case we cunningly assigned this to be 2p and 0 and 2q to r instead of p, q, and r, simply because it makes math easy. And if you hadn't done that, if you just call this p and 0 and q and r, that would have worked just fine. You just have dealt with some fractions, which I'm sure you can also do. So this is just a proof of the mid-segment theorem. Until next time, as-salatu wa-salamu ala rasulillah wa alhamdulillahi rabbil alamin. Assalamu alaikum.